So this is lesson number 25, solution of equations in Algebra 1. So lesson number 25 there. Alright, and what we're going to do here is basically solve equations. Solving equations means that if we have an equation like this, and we want to solve it, we're trying to find out what number x has to be in order to make that a true statement. So if you remember from pre-algebra, in order to get that x value, we have to get the x by itself on one side of the equal sign. Doesn't matter which side, but most people usually pick the left-hand side for the x value to be all by itself. So that means we need to get rid of the 4 and the 5. And the way we do that is we do the opposite of what it says. So here it says add 5. So in order to get rid of that 5, we are going to subtract 5 from here and subtract 5 from here. So you always try to get rid of the numbers added or subtracted to the x first, and then get rid of the number that's multiplied or divided by the x. Okay, dang, I keep getting these phone calls. Alright, so let's continue on with what we've got here. When we bring these two together, those go away. Positive 5 and a negative 5 is 0, and that's what we want. We want it to go away. 17 minus 5 is 12. And then we divide by 4, because we're trying to get rid of the 4 in front of the x, and in order to get rid of it, we divide both sides by that number. So those go away, and 12 over 4 is 3. And that's what we're looking for there. We're trying to solve the equation, which means we're trying to find the x value. Alright, let's look at example 25.2. In this case, we have negative 5m plus 6 equals 8. And again, we're going to get rid of the number that is added to the m. So we'll subtract 6. That doesn't look like a 6, does it? And we subtract 6 here. So those go away. Negative 5m equals 8 minus 6 is 2. Now we're going to divide by negative 5 here and negative 5 here so that those go away. And we get m equals 2 over negative 5, or negative 2 over 5. So remember, 2 over negative 5, negative 2 over 5 with the negative in the middle, or we can put the negative on the 2. It doesn't matter. As long as there's one negative, it doesn't matter where it goes. In front of the 2, in front of the 5, it doesn't matter. It means the same thing. So you can put that negative anywhere you want to put it on. Alright, so let's look at example number 25.3. Clear my board here. 25.3, negative 7k minus 4, and they're just getting you used to using different letters. The letters all mean the same thing. We don't know what they are yet. So we're going to add 4 here, add 4 to here. Those go away. Negative 7k equals negative 21 plus 4 is negative 17. Divide by negative 7, divide by negative 7. Those go away. Two negatives give you a positive, and there's your weird answer, 17 over 7. Okay, so if we go ahead and do number 25.4, and this time they're using the letter P, plus 5 equals 17. Okay, we're going to get rid of the 5 by subtracting, and we get negative 11p equals 12, 17 minus 5. Divide by negative 11, divide by negative 11, those go away, and we get negative 12 over 11 for an answer. Alright, so let's do one that's a little trickier that has to do with fractions. And we just follow the fraction rules just like we always do. Add 1/2 to both sides. Okay, so when we add 1/2 here, these go away. So we have 1/5 m equals 3/4 plus 1/2. So we have to find common denominators. So we're going to change that to a 4 on the bottom and a 2 on the top. So now we have common denominators. 2/4 is the same as 1/2. And then we have 1/5 m equals 5 over 4. Adding our fractions, you just add the numerators and put the denominator on the bottom. Now we divide by 1/5. Whatever number we multiply by m, we divide. Doesn't matter, and it always goes away. We divide by 1/5 over here, which, if you remember, you invert and multiply instead of actually divide. You don't divide fractions. And we get 5 times 5 is 25, and 4 times 1 is 4. So m equals 25 over 4. And our final problem will be 25.6. It's 0.4x minus 0.2, and that's going to equal negative 0.16. Everything's done the same way. Got a number subtracted from the x, we add it, and we add it. You always do the same thing to both sides. Those go away. So we've got a negative 0.16 plus a 0.2. So remember, when we have signs that are opposite, we take the opposite of the two and put the sign of the largest one on top. And this is the largest one. So we're going to get 0.04 here, 0.4 here. The book, for some reason, has a negative in front of that. That is not right. Alright, and then we divide by 0.4. Because the 0.4 is multiplied, we divide. Those go away. So we take 0.04 divided by 0.4, and we get x equals 0.1 for our answer. And that is what the book says, so I'm not sure what they messed up there. But anyway, their answer of negative 0.04 should be a positive. And that's it for problem set number 25 in Algebra 1.